Dear students, welcome back for the third session of the numericals related to the structure of an atom. So I think previously we have discussed in the first and the second sessions 6 and 9 different numericals. That is totally we have solved nearly 15. Okay. So now we will have the 16th numericals. It is based on actually the de Broglie's equation, that is the dual character of an electron, which behaves to be the both the wave nature as well as the particle nature. Okay, so let us solve this first. Calculate the wave number for the longest wavelength transition in the Balmer spectrum or Balmer series of the which atom, atomic hydrogen or hydrogen atom. Okay, so first nu bar we have to find out. What is nu bar here? It is wave number. Okay. So then the longest wavelength, wave number for the longest wavelength. So here for Balmer series, which series here? Balmer series. N1 is equal to 2 first. In addition to that, with longest wavelength means longest wavelength refer to N1 is equal to 3, N2 is equal to 3. Okay. If it is the least wavelength means as the smallest wavelength means N2 is equal to infinity. As if I have mentioned in the theoretical concept, to get a wave number or wavelength or whatever it may be in the given series, N2 is equal to N1 plus 1 will have the longest wavelength, and then the smaller wavelength or the smaller wave number is going to be the what? N2 is equal to infinity. As if it is the longest wavelength means N2 is equal to 2 plus 1, that is equal to what? 3. Okay. Apply the what? The Rydberg's equation. Nu bar is equal to, we know that first. What we know that here? Nu bar is equal to R into 1 upon N1 square minus 1 upon N2 square. R is 1.09678 into 10 to the power of 7. That is called Rydberg's constant into 1 upon 2 square minus 1 upon 3 square. 0.9687 into 10 to the power of 7. Here square is 4, here it is a 9. 9 4s are 36 is the LCM here. Here it is 4 means it is 9 minus here it is 9 means it is 4. So total it is 1.09678 into 5 into this, because the difference is going to be this 10 to the power of 7 divided by what? 36. When I simplify that, I will get the final answer in the form of 1.5233 1.5233 into 10 to the power of 6 in terms of per meter. Actually we are getting 0.15233 into 10 to the power of 7, or I can convert that in the form of what? 1.5233 into 10 to the power of 6 in terms of per meter. Because why we are using the per meter means it is a reciprocal of what length? Wavelength. Wavelength this means it is in meter. Therefore wave number must be in what? Per meter. Okay. So that is about the longest wavelength transition with respect to the Balmer series. The wave number is going to be the 1.5233 into 10 to the power of 6 per meter. Okay. So let's move on to the 17th. What will be the wavelength of the which one? Wavelength of a ball of mass how much? 0.1 in terms of kg, moving with a velocity of how much? 10 meter per which one? Second. Means the wavelength. So as if I mentioned in the previous, it is based on the dual character, that is the wavelength we have to find out. It is having a mass and then having the velocity. Means we have to prove that it is having a dual character as well as the water. That is both the wave character as well as the particle or the matter character here. So here first we have to get the value of which one? Lambda, wavelength. Having a mass is 0.1 in terms of kg. Already the SI unit is given. And this is moving with a velocity of how much? 10 in terms of meter per second. Therefore, all are in what? SI units. Therefore, by de Broglie's equation, which equation? De Broglie's equation. Lambda is equal to what? Directly I will write that here. Lambda is equal to what? H divided by m into v. That is equal to. What is H? Planck's constant. 6.6261 into 10 to the power of minus 34 in terms of joule second divided by what's the mass? 0.1 in terms of kg, and the velocity is going to be what? 10. So I think this becomes 1 actually. Therefore, the value is going to be 6.6261 into 10 to the power of minus 34 in terms of meter, because as if it is a wavelength. Okay, so that is a wavelength related to the de Broglie wavelength of a ball which is having a mass of 0.1 in terms of kg and having a velocity of 10 meter per second. That is 6.6261 into 10 to the power of minus 34. Okay, so that is 37. Let's move on to the 18th here. Calculate the mass of a photon with a wavelength of how much? 3.6 in terms of angstrom. So here we have to find out the mass of a which one? Photon. And it is having a wavelength. Photon means indirectly it is the ejection of an electron here. Mass we have to find at m. Okay. Lambda wavelength is given as 3.6 angstrom, that is equal to 3.6 into 10 to the power of minus 10 in terms of meter. What is again the de Broglie's equation? By what equation again? De Broglie's equation. What is equal to what? Lambda is equal to h divided by what? mv. What I need actually, m is equal to h divided by lambda into v. Lambda into v. Sorry. What is h? 6.6261 into 10 to the power of minus 34 in terms of joules second. What is the wavelength here? 3.6 into 10 to the power of minus 10 in terms of which one? Meter. And the velocity means it is nothing but the velocity of an electron or the speed of a light, that is equal to 3 into 10 to the power of 8 meter per second. So upon simplification, so we will get the value in the form of mass of that one is going to be the 6.13 into 10 to the power of minus 33 in terms of SI unit for mass is going to be the what? Kg. Okay. So just he has given the what length? Wavelength is given, just we have to find out the value of which one? Mass. Again applying the what equation? De Broglie's equation, lambda is equal to h divided by mv, or mass is equal to h divided by lambda into v. But the velocity is nothing but the speed of a light, that is equal to 3 into 10 to the power of 8 meter per second. Okay. So that is about the numerical number 18th. Okay. So let us now have the next in the form of 19. If the which one? Velocity of an electron in the first Bohr orbit is going to be 2.19 into 10 to the power of 6 meter per second. Calculate the de Broglie's wavelength associated with same. Just the thing is, here he has given the velocity, I think. Now we have to calculate the value of which one? The wavelength. De Broglie's wavelength. So velocity of an electron, v is equal to how much it is? 2.19 into 10 to the power of 6 in terms of what per watt? Meter per second. Then we have to find out the what length? De Broglie's wavelength, that is equal to lambda. We know that lambda is equal to h divided by mv. H is known, v is known, but what is m? M is indirectly the mass of an electron. What is mass of an electron? 9.1 into 10 to the power of minus 31 in terms of which one? Kg. It is the mass of an electron. Therefore, again by what equation? Same. What is that? De Broglie's equation. Lambda is equal to what? Lambda is equal to h divided by what? Same, mv. H is what? 6.6261 10 to the power of minus 34 in terms of joule second divided by what's the mass of an electron here? 9.1 into 10 to the power of minus 31 in terms of kg into velocity for that one is going to be 2.19 into 10 to the power of 6. So on simplification, I will get the value in the form of how much? 3.32 into 10 to the power of minus 10 in terms of which one? Meter. 3.32 in terms of into 10 to the power of minus 10 in terms of meter. Or I can use directly in the form of 3.32 in terms of which one? Angstrom. Why it is angstrom? Because 10 to the power of minus 10 meter is called as what angstrom? 1 angstrom. That is equal to 3.32 in terms of angstrom. Okay. So that is, these are the numericals that has been related with respect to the which one? De Broglie's equation. Means we are proving not only it is having the wave nature, but also it is having a another one is what is that? The particle nature, or it is also called as a matter. Okay. Let's move on to the 20th. The mass of an electron is given as 9.1 into 10 to the power of minus 31 in terms of which one? Kg. If its kinetic energy is found to be 3 into 10 to the power of minus 25 in terms of joules, then what is its, or calculates its what length? Wavelength. Means instead of velocity, he has given that in the form of which one? The kinetic energy. So it is also the modified with respect to which one? The de Broglie's equation in terms of what energy? Kinetic energy. So first, mass of an electron m is equal to 9.1 into 10 to the power of minus 31 in terms of kg. Okay, mass of the electron is given. Then what is its kinetic energy? Kinetic energy is equal to what? 3 10 to the power of minus 25 in terms of joules. Then calculate its what length? Wavelength. So what is the formula which relates the wavelength with respect to kinetic energy? Okay. So lambda is equal to h divided by root of 2m into what energy? Kinetic energy. That we have actually done in case of which one? The theoretical concept. That is, lambda is equal to, first we know that h by what? mv. Also, half mv square we know that it is called as what energy? Kinetic energy. Therefore, what is mv square is equal to 2k. Or what is m square v square is equal to 2m into kinetic energy. What is mv? Root of 2m into what energy? Kinetic energy. Means instead of what? Mass into velocity, it is given as root of what into what? 2m into what energy? Kinetic. Means lambda is equal to h divided by what? 2m into root of what energy? The root of 2m into what energy? Kinetic energy. What is this? 6.6261 into 10 to the power of minus 34 joules per second. Joule second, sorry. Root of 2 into what is the mass of an electron again? 9.1 into 10 to the power of minus 31 in terms of kg. And what is the kinetic energy here? 3 into 10 to the power of minus 25. Okay. So upon simplification, I will directly write the answer in the form of, or I can write that in the another step, that is 6.61 into 10 to the power of minus 34. So this on simplification, this is around minus 56. Minus 56 means 10 to the power of minus 28, I think. This becomes 10 to the power of minus 28. And this 2 into 9.1 is 18 point something, 18 3s are 54. 54 means it is 7 point something. What is that 7 point something here? 7.389. 7.389. That is equal to, on simplification, I will get the value in the form of 0.8967. 0.8967 into 10 to the power of minus 6 in terms of which one? Meter. Or 8.967 into 10 to the power of minus 7 in terms of meter, which can also be equal to 896.7 into 10 to the power of minus 9 in terms of meter, which is equal to 896.7 in terms of nanometer. Okay, this is the first answer, and then we can change this. Or if I strictly that instead of mentioning that in the form of 10 to the power of minus 7 or minus 9 or lengthy, it is finally mentioned as 896.7 in terms of what meter? Nanometer. So just You have to know the direct formula. What is the direct formula? Lambda is equal to h divided by what? Root of 2m into what energy? Kinetic energy. Okay. So next we will move on to the numerical number 21st. A microscope using a suitable photons is employed to locate an electron in an atom within a distance of around 0.1 in terms of which one? 0.1 in terms of angstrom. What is the uncertainty involved in the measurement of its velocity? Means it is indirectly called as, what's that? It is a Heisenberg uncertainty principle. Heisenberg uncertainty principle means it is highly impossible to determine exactly the position as well as the momentum of the revolving electron precisely or exactly. Means if I know the exact position, I can find out it doesn't find the momentum. If I know the exact value of momentum, I can find out the position. But simultaneously the exactness of both the position and then the momentum cannot be measured. Means we can find out only the change, and that change is called as what? Uncertainty. What is the uncertainty here? Uncertainty involved in the measurement of its velocity. Means we have to find out delta V first. Delta V. Okay. A microscope using a suitable photons is employed to locate an electron in an atom with a distance of, means position it is not exact, it is delta x is given as how much? 0.1 in terms of angstrom or 0.1 into 10 to the power of minus 10 meter, or indirectly it is 10 to the power of minus 11 in terms of meter. What is 10 to the power of minus 11? It is uncertainty, or indirectly to locate an electron its distance is found to be the 0.1 in terms of which one? Angstrom. Okay. So let us have the next one. Then what is the mass of an electron? As if it is a photon, means we can have the mass of an electron. What is that? 9.1 10 to the power of minus 31 in terms of which one? Kg. Okay. By HUP, what is that HUP? Heisenberg uncertainty principle. Delta x into m into delta v is equal to h divided by what? 4 pi. H divided by what? 4 pi. Here actually delta x into delta p actually. Delta p is called as uncertainty in the momentum. But what is momentum? Mass into velocity. Therefore, uncertainty in the momentum is equal to product of mass into uncertainty in its respective velocity. Therefore, what is delta v? I think delta v is equal to h divided by 4 pi delta x into what? M. Okay. So, what is h as usual? 6.6261 into 10 to the power of minus 34 in terms of joule seconds divided by 4 into 3.142, I think 22 by 7 is 3.142. Then what is the change in this one? Delta x is found to be 10 to the power of minus 11 into, what is the mass of an electron? 9.1 into 10 to the power of minus 31. On simplification, the value with respect to the delta v is found to be 5.79 into 10 to the power of 6 meter per second. Means the uncertainty in the velocity of an electron is found to be 5.79 into 10 to the power of 6 watt per watt meter per second. Means he has given uncertainty in the position, or it may be the location. Means the delta x is found to be the 0.1 in terms of angstrom. But as we have to need that in the SI unit, it is in terms of meter. Therefore, 0.1 angstrom is nothing but 0.1 in terms of into 10 to the power of minus 10 in terms of meter, or it is on simplification 10 to the power of minus 11 in terms of meter. And as it is a photon, means it is the mass of an electron. Mass of an electron is found to be 9.1 into 10 to the power of minus 31 in terms of kg. Then by applying the Heisenberg uncertainty principle, we can say that delta x into m into delta v is equal to what by what? H divided by what? Pi. 4 pi. Okay. So let us move on to the 22nd here. A golf ball has a mass of how many grams? 40 grams. and a speed of 45 meter per second. If the speed can be measured within an accuracy of how much percent? 2%. Then calculate the uncertainty in the position. Calculate the what position? Uncertainty in the position. Uncertainty in the position means we have to find out the value of delta x. Delta x. It is having a mass. Golf ball is having a mass of how many grams? So that is equal to 40 into 10 to the power of minus 3 in terms of kg. Why? Because we have to convert that into SI unit. 40 grams means 40 into 10 to the power of minus 3 in terms of kg. Then the velocity or the speed of that one is found to be 45 in terms of meter per second. It's actually exact, but it is an uncertainty is given. What is that? If the speed can be measured within accuracy of 2%, means the uncertainty of that one is found to be the 2% of, delta V is equal to 2% of V, original V. That is 2 by 100 times the, what is the velocity here? That is 90 by 100. 90 by 100 means it is 0.9 in terms of watt per watt, meter per second. What it is? Uncertainty in the velocity. Again by applying the what? HUP. What is that HUP? Heisenberg uncertainty principle. Delta x into m into delta v is equal to h divided by what pi? 4 pi. Or what I need actually? Delta x. Delta x is equal to what? H divided by 4 pi into m into delta v. M into delta v. What is h here? What is h? 6.6261 into 10 to the power of minus 34 in terms of joule second. 4 into 3.142. 20 pi is value is 3.142. What is the mass given? 40 into 10 to the power of minus 3 in terms of which one? Grams. Kg. And then what is the uncertainty in the velocity? This 2% of V, that is equal to 0.9. Okay. Upon simplification, I will get the final answer in the form of 22nd 1.46 into 10 to the power of minus 33. 10 to the power of minus 33. Position means it is in terms of meter. Okay. So means here the speed is given in the form of 45%, but the uncertainty that we are measuring according to the Heisenberg uncertainty principle, it is just only the accuracy is just only 2% of the original. What is the 2% of original? Means delta V is equal to 2% of V. That is 2% means 2 by 100 into how much? Original velocity is 45. On simplification, the uncertainty in the position is going to be 0.9 in terms of meter per second. Then apply the, as usual, what principle? Heisenberg uncertainty principle formula, that is delta x into m into delta v is equal to what by what? H by 4 pi. Okay. So this is about the numerical number 22. Let's have the 23rd here. Next is if the position of an electron is measured with an accuracy of how much? 0. Plus or minus 0.002 in terms of nanometer position. Calculate the uncertainty in the momentum of an electron. Suppose the momentum of an electron is given as h divided by 4 pi into 0.05 in terms of nanometer. Is there any problem in defining this particular value? So here we have to calculate one uncertainty in the momentum, and he has given it is, we have to calculate, and the uncertainty in the momentum is given as h divided by 4 pi into 0.05 nanometer. If this be the case, is there any problem in defining this particular value? Whether this can value of delta p, or it is also called as the uncertainty in the momentum, is going to be possible or not? That we have to prove. Okay. So let us have delta x is equal to 0.002 in terms of what meter? Nanometer. Nanometer means that we have to convert that in the form of which one? Meters. Nanometer, sorry. 1, 2, 3. nano means 10 to the power of minus 9. 1, 2, 3. 2 into 10 to the power of minus 12 in terms of meter. Directly I will write that in the form of 2 into 10 to the power of minus 12 meter. Delta P calculated is equal to h divided by 4 pi into m into delta x. 6.6261 10 to the power of minus 34 divided by 4 into 3.142 into mass. Electron means what is the mass? Already we have to know that's 9.1 in 10 to the power of minus 31 in terms of kg. What is the delta x given? It is 2 10 to the power of minus 12. 10 to the power of minus 12. Okay. Upon simplification, I will get the final answer in the form of 0.2637 into 10 to the power of minus 22. Momentum means mass into velocity means kg meter per second. This can also be written as 2.637 into 10 to the power of minus 23 in terms of kg meter per second. What is this? Delta P for calculated. Also, there is another one. What is that? What is delta observed here? Delta P actual given is, it is how much it is? H divided by 4 pi into 0.05, 05 or 05, okay, only 05 I think, 05 in terms of nanometers, that is equal to 6.6261 into 10 to the power of minus 34 divided by 4 into 3.142 into 0.05 into 10 to the power of minus 9, that is equal to, I will get final answer for that, 1.055 into 10 to the power of minus, how much it is? 24. Minus 24 in terms of kg meter per second. Kg meter per second. So this actual is given and then the calculated is given. So here compare these two values. What's that? This and this. 1.055 is found to be the actual and the calculated value is found to be the minus 23. Means this is found to be the lesser as compared to that of calculated. Means the actual uncertainty in the momentum is found to be the less than that of the calculated momentum. Means it cannot be well defined. Means there is no problem, there is a problem in defining this particular value. Okay. So that we have to write that in the form of sentence here. As, what is that? Delta P of actual is less than delta P what we have calculated. It cannot be defined exactly. We can't exactly define the position or it may be the momentum of an electron because the actual momentum is found to be less than as compared to that of the which one? The calculated. So that is the, already we have calculated that according to the numericals in the form of which one? The delta x and then the mass of an electron along with the 4 by h values, that is found to be 2.637 10 to the power of minus 23 in terms of kg meter per second. But he has also given one hint, that is, suppose the momentum of an electron is given by h divided by 4 pi into 0.05 in terms of what meter? Nanometer. On simplification is this value becomes 1.055 into 10 to the power of minus 24 kg meter per second, which is found to be the actual. So compare the actual with respect to the calculated. Actual means it is nothing but the experimental condition. So experimental value, as we know that it is found to be less than as compared to that of the calculated, we can't exactly define the position of that one. That is, the momentum of that particular cannot be well defined. Okay. So that is about the numerical number 23. Okay. Let's move on to the next one. Let's have Calculate the energy associated with which one? Calculate the energy associated with the first orbit. It is actually first orbit. There is some mistake here. First orbit here of helium plus. What is the radius of this particular orbit? Okay. For first orbit of He plus means Z is equal to 2 and N is equal to 1. Because atomic number is going to be the 2 for helium, and then the first orbit means N is equal to 1. First we will have the energy is given by minus 2.18 into 10 to the power of minus 18 into Z square divided by N square in terms of joules. That is equal to, how much it becomes? Minus 2.18 into 10 to the power of minus 18 into Z square is 2 square divided by 1 square into 4, actually it is 8.72 minus 8.72 into 10 to the power of minus 18 in terms of which one? Joules. That is the energy with respect to the first orbit of helium. Okay, and similarly we can calculate the what? Radius of this orbit. What is that radius of this orbit? Radius of this orbit is given by 0.529 in terms of N square by Z, that is equal to, in terms of angstrom. If the 0.529 is the case, it is angstrom. That is equal to 0.529 into N square is what? 1 square divided by Z is 2. That is equal to, on simplification, 0.2645 in terms of angstrom. 0.2645 is in terms of which one? Angstrom. Okay. So that is about the or if I want to that in the SI unit, 0.2645 into 10 to the power of minus 10 in terms of meter, which is also equal to 2.645 into 10 to the power of minus 11 in terms of meter. Okay. So that is the radius with respect to the first orbit of which ion? That is helium plus ion. Okay. So this is about the completion with respect to the numericals of structure of an atom. So means we have solved on the basis of which one? The Heisenberg uncertainty principle. Then we are having the energy with respect to the orbit of the hydrogen like species, and then the radius also. Then we have calculated the velocity. Then we are using the de Broglie concept. Then the Rydberg's equation to calculate either the wave number, or it may be the wavelength, or it may be the frequency. Okay. So then we know the concept of which one? E is equal to h nu or E is equal to hc by lambda. That is according to the Planck's quantum theory of which one? The radiation. Okay. So this completes the theoretical concept along with the numericals problems related to the most important topic in the first PU in the form of the structure of an atom. Okay. So in the next session we will start the competitive MCQs related to the same chapter, that is called as the structure of an atom. We will have the solving of multiple choice questions related to this particular structure of an atom. Okay. So that we will discuss in the upcoming sessions. Okay. So thank you.